All right, we're gonna pop in here and keep going with some of these um, integration multiple choice questions that we were doing maybe a couple days ago or something like that, depending on what class you're in. But I think I got question 16 to something in the 20s. I don't remember. We'll go through and do all of them here. All right, so these are starting to get into U sub type questions. This first one you might be able to do without use, but you can do it with use if you want. It's got bounds, so go ahead, hit pause, give this one a shot, and then I'll flip over to the answer. Here comes the answer. All right, so I did this. I didn't show all the U work here. I just, we're integrating e to the negative 4x. So it's going to get an e to the negative 4x, but I need that 1/4, the negative 1/4 out front to balance out the chain rule if I were to derive this. If I were to derive this, I'd want to get that back. I'm going to evaluate that between 0 and 1, which gives me negative 1/4 e to the negative 4. That's 1 plugged in, minus a negative 1/4 e to the 0. This e to the 0 is 1. So this guy right here, I get a double negative. When I do e to the 0, I get 1, so that gives me 1/4 by itself, minus 1/4 e to the negative 4th, which is D. Next one is question 17. This one's definitely a U sub. So I'm not going to give you any hints for the U sub yet. I think you should try to see if you can remember how to do it. I guess I will say one thing. I'll say careful with the negatives. Make sure you paused it and you did it. I'm going to flip to the answer in just a moment. Here it comes. Bam. Oop, not yet. All right, question 17. Remember, I make U this 4 minus x squared. It's the biggest it can be, right? It's not just negative x squared or x squared. I make it as big as possible, 4 minus x squared, and it's the function that's interior to another. It's interior to that square root. So once I do that, I get a du as negative 2x dx. I want to match it to this. So I got to divide by negative 2. That gives me a negative half du equals x dx. This is the x, and that's the dx. You could pop this over to the other side there, and it would be exactly what I have here. Whenever I'm doing u sub and I get that coefficient of 1/2 or negative 1/2, whatever it is here, I usually like to just put it out front to kind of get it out of the way, so I don't got to think about it. So I can just do the, in this case, power rule on this thing. So I got u to the 1/2. What do I get when I integrate that? I get u to the 3/2. And then I need to divide by that 3/2. Since it's a fraction, a lot of you say copy dot flip or whatever, right? Multiply by the reciprocal. We do the opposite of this guy. Instead of 3/2 is 2/3. And this negative 1/2 is that negative 1/2. The 2's cancel, give me a 3. And then I plug my original u back in, and I get this, which matches with E. Question 18, another U sub one. If that one, the last one we did, was a refresher for you, then hopefully you can do this one. Just be careful with your trig integration. Negatives, which ones have them, which ones don't, right? All right, pause and do it, please. Here it comes. The u is my x cubed. It's inside of the cosine. The du is 3x squared. Divide by 3, 1/3 du is x squared. If you want to have a dx right here, you could. And then I'm integrating cosine u du with the 1/3 out front, just like I talked about in the last one. And this one actually does not get a negative because I'm integrating sine, which means it's going to integrating cosine into sine. And then think about it, well, if I were to derive sine, what would I get? It would get positive. So it matches, I don't need a negative. So 1/3 sine u plus c. Then I plug the u back in, 1/3 sine x cubed plus c, which is B. Question 19, another U sub here. You might, let me zoom out a little bit. You might be able to do this one, if you're savvy, without, badoop boop, without doing U's, but I would still suggest doing it. So pause, do it, please. Comes the answer. I got A. U is the interior, 3x plus 1, badoomp. Du is 3dx. Notice I got a 1, an invisible 1 there. So I'm going to divide by 3. 1/3 du is dx. So I get 1/3 u to the 5th du. Integrate. 3 times 6 is 18. Where did the 6 come from? Dividing by the power rule for u to the 6th from u to the 5th. So my answer is A. Let's go down to the next one. All right, so this one is a U sub definite integral, and like you're not actually solving it, right? They want to see that you can change it over correctly. There are two things that you need to be careful with. This, well, three. This, the correct coefficient, and your bounds. I'll leave it at that for now, because we're gonna do another one that's just like this one in a moment. So I want you to try and see if you can figure this out on your own without me helping you. So hit pause, give it a shot. Here it comes. Sorry. All right. So, u is the 2x plus 1. Du is 2x dx. 1/2 du is dx. That way I got the dx. So I got 1/2, just move it out front, root u with a du. But notice I did not put bounds here, right? I think that the easiest way to get this one incorrect would be to select, is it B? Yep, B. So to do this work, but to not change the bounds here, right? This is this integral right here is dx. That means that there's 0 and this 2. Those are x values that I'm integrating to. Think about all the visual ones that you do. You start at an x value, end at an x value. Well, now we're in du, so I need to have u values here. Now, there's a chance that the u and the x values would be the same, but usually they're not. So what I need to do is figure out what u values go with the x value of 0 and the x value of 2. How do I do that? Well, it's really convenient that I have this u equals 2x plus 1. It relates u and x. So I can plug in the 0 and the 2 for x's here and figure out what u's go with that. And then those become my new bounds. So to do that, I get u as 0. Remember 2x plus 1, so it's 2 times 0 plus 1, which gives me 1. And then u of 2 is, remember it's 2x plus 1. 2 times 2 plus 1 is 5. So my bounds change to 1 and 5, and I get the 1/2 integral of u, root u du, which is C. So hopefully, if you that's one that people like kind of forget a lot. So if that was a refresher, now like, oh, I see it, then you can think the next one is one of these. Question 21. Okay. Here we'll go there. All right. So same thing. Do the conversion to figure out what one of these would be the correct use. One thing I'll say, root x, that's this guy. This one does have some tricky factor to it. But anyway, go ahead, try it. All right, here comes the answer. Excuse me. All right. So the answer is C. You may say, okay, help me out here. Where'd that come from? Well, it's e to the root x, and then I wrote this piece right here so that y'all could see it as 1 over root x dx. Why did I do that? Well, because I know that this u of root x, which they tell me to do, is going to be that guy. The du gives me 1 over 2 root x dx. So here, notice, if I were to like do some fraction work here, this little circle is equivalent to this stuff right there, right? This is 1 over root x, and then there's a dx. So notice when I do my du, I get 1 over 2 root x dx, so I double everything and get 2 du is 1 over root x dx, and that matches this thing. Then I've got 2 integral e to the u du. I haven't done the bounds work yet. I would have left that blank at this point. Now I got to figure out what u values go with that. So u of 1 is just root of 1, which gives me 1. U of 4 is root of 4, which is 2. So my bounds switch from 1 to 4 to 1 to 2. Hopefully that helps. You're feeling good. Okay, 22. Integral from 0 to pi of sine of 3x dx. You can do it. Go ahead, pause, give it a shot. Comes the answer. All right. So I wonder if this one, the most work is all the trig, because I know you guys love trig, but really it's just, when you do it right, it's just these points on the unit circle. Anyway, or maybe the negative, right? So it's got a little u sub, negative 1/3 cosine 3x, evaluated from 0 to pi over 3, which then I plug in my pi over 3, right? And I plug in my 0. So that gives me negative 1/3 cosine. Well, this is just pi, right? And that's 0. So, and I've got a double negative there, minus and a negative, right? So that gives me my plus here. And then what's the cosine of 0? Well, the cosine of 0 is 1 because that's the x-coordinate. What's the cosine of pi? Well, over here, the x-coordinate is negative 1. So this negative is there. This guy is negative 1. So this actually gives a double negative to a positive 1/3. This is also 1/3. What's 1/3 plus 1/3? It's 2/3. So the answer is D. All right, got to speed up because we're running out of time. All right, so last one is there. Hit pause, give it a shot. Okay, here comes your answer, and I will squeeze it into my 2 minutes here. All right, so my u is the thing in the root in the bottom, 1 plus sine theta. Du is cosine theta. That's convenient. There's no coefficient work. Sorry, the answer is D. I guess I should have said that. So I get du over root u. I got to integrate that. That's u to the negative half. What's 1 above negative 1/2? Well, it's a positive 1/2. Where does the 2 come from? It comes from dividing by a half, multiplied by the reciprocal. From there, I get 2 root 1 plus sine theta evaluated between 0 and pi over 2. So here's my 0, here's my pi over 2. Notice sine of 0 is 0. Sine of pi over 2 is 1. So this gives me 1, right? And this guy gives me 0. There's no like double negatives or anything crazy here. It's kind of nice in that sense. 1 plus 1 is 2, so I get 2 root 2. 1 plus 0 is 1, so I get root 1. What is root 1? Well, it's just 1, because 1 times 1 is 1. So I get 2 root 2 minus 2, which it isn't up there, but if I were to get to this point, then I look here and I'm like, oh, this is a factored version of that. So I go and select D. So hopefully after these, I think that's the last one it is. Hopefully after all these videos, you are feeling pretty solid with your ability to do these integrals, and we are ready to move on and then tackle that AP test soon. Bye.